It's quite straightforward to test whether or not points are collinear. Now, what does collinear mean? Well, co is together and linear is a line. So collinear means together on the same line. So that's the first thing that we need to know. Now, if points A, B and C are collinear, then AB has to be parallel to BC, because after all, if they're all going to be on the same line, A here, B here, and C here, no matter which way that line goes around, it wouldn't necessarily be vertical. It makes sense that if you know that this line and this line are parallel, and B is actually on both lines, then you found that they're all on the same line. So that's the way you test for them. Now, an important sort of definition here that you probably need to put a bit of a box around or just pay attention to is that to be parallel, two lines have to have the same gradient. So you're really just checking if the gradient is the same, but don't forget that there's one important exception. Vertical lines have an undefined gradient. So as you go to find their gradient, you're not going to get an answer. So you need to really pay attention to that fact that being parallel means having the same gradient or both being vertical. All right, so let's have a look at an example here. Are these points A, B and C collinear? All right, well the test for that is if they're all together on the same line, then this line, AB, has to be parallel to that line, BC. And since B is on both of them, obviously they're all on the same line. So the way we'd set it out is just say gradient of AB. Now we can use the y2 minus y1 over x2 minus x1 formula. So it doesn't matter which ones are our 1s and 2s, remember, as long as if we're starting, say, with the 5, on the bottom we've got to start with the minus 2. So let's do that. We've got 5 minus 3 over minus 2 minus 1. So that gives us 2 over minus 3. Now, I can just put the negative out the front. See how I've got a positive answer on the top and a negative answer on the bottom. It doesn't really matter whether you put the minus down the bottom or up the top. I'm just going to put it floating out the front because to me that makes most sense and it looks tidy. It's not wrong to write it down the bottom, but we're thinking it's a negative gradient. It's a negative 2/3. Okay, so then we can do the gradient of the other interval. The gradient of BC using these two, and again, it doesn't matter which are your 1s or your 2s, just make sure you start with the same one. I'm going to start with the 3 and then the 1, so I'm going to do 3 minus minus 1. And I actually write it like that. You might just jot down 3 plus 1. I just keep it really straightforward on the first line of working, and then I tidy up on the second line. And then I need 1 minus 7. Now 3 minus minus 1, that's 3 plus 1, which is 4. And 1 minus 7 is minus 6. So at that point I'll see it's the same as this because I can halve the top, halve the bottom. And I've got the negative down the bottom, but see, I know that that means it can just float out the front as well. So that's the same as negative 2/3, isn't it? So I can say here, gradients are equal. Therefore, AB is parallel to BC. Therefore, A, B, and C are collinear. So you always want to finish a question like this with a nice simple statement that really answers the question. Are they collinear? You say yes, A, B, and C are collinear.